Welcome to this video about using data in Matlab. The first thing to do is to locate the file that you're using. My particular file is here in a folder on my desktop called sample data, and I'm going to be using preferredwalking1.mat. When you open Matlab, Matlab doesn't know where to go to find your data. So the first thing you're going to need to do is use the toolbar up here to find where you want to go and browse to where your data is. So I'm going to go to desktop because that's where my data is, and I'm going to select the folder sample data because all of my data is in there. So I'm going to select that folder and I'm just going to be working in there. In the Matlab command window, I've loaded the preferredwalking1.mat. .mat is a file that's proprietary to Matlab that they use to store data. It's not actually variables in and of itself, but over here in the workspace, I can see that inside that preferredwalking1.mat, there's a single variable because that's what showed up in the workspace on the right-hand side of my screen. Usually, if there's just one variable, it's named whatever the file name was. So preferred, I'm going to type preferred walking one, and you'll notice right away that after I hit the space, the words turned purple, which is not a good sign in terms of what Matlab is looking for. So Matlab doesn't take spaces in any of its variable names. And if I click over here on the workspace, you can see right here at the end, it's an _1. So it's replaced all of those spaces with underscores. So when you're working in Matlab, it's generally a good idea to just ignore spaces altogether. So either capitalize the first letter of each word or use an underscore. There are some times it doesn't do very well with dashes, so an underscore is generally better. So I'm going to type preferred_walking1.mat, and it's going to tell me that there's no existent field mat. So that's because the extension doesn't end up in the variable name. So preferredwalking1 gets me this structure. So Matlab has several different ways that it stores data. One is just in a plain variable. Another is in structures. Structures allow you to save multiple things, multiple kinds of data, all inside one single variable. And actually, we could tell that it was a structure just by looking over here at the workspace. If we want to get a data for our force, so maybe we want to call this force data or data force, then we need to pull that force data, which is here inside the structure, out of the variable and into a variable that we can manipulate. So right now, I've typed data_force on the left side of my equal sign. I'm going to define data_force, and I'm going to define it as preferred_walking_1 dot force to access the force inside there. And I'm going to put a semicolon on the end to suppress the output. And as I hit enter, over here on the right-hand side in the workspace, we get this data force variable right there. Now, I'm going to do the same thing with time, but there's no actual time in here. So what I want to do is there's a 500 frames and the frame rate is 100. You can see both of those things. I'm going to go ahead and say frames equals my preferred walking one dot, which I'm just going to copy so I don't have to type it all the time, preferred walking one dot frames. And I'm going to make sure that I case match because MATLAB doesn't like it if you don't. Then I'm going to do the same thing. I up arrowed there, and I'm just going to call this frame rate and change this to frame rate. We're going to go ahead and start by defining a time vector here that is 0 to 1 over my frame rate to the number of frames minus 1 parentheses divided by the frame rate. So if you stop to think about what I've done there, I've said I want to go by whatever the frame rate is, that's my time step, that's my delta t, and I want to go to 1 less than the number of frames that I have converted to time. I'm dividing by the frame rate to convert to time. And it's 1 less because I'm starting counting from 0. So if I do this and I hit enter without a semicolon on there, Oh, we're going to get an error. I mistyped a variable name and MATLAB helpfully corrects that, and you can see that I get a whole long list of values. So I didn't like all that clutter in my command window, so I used the command CLC to clear everything in my command window. Now what we want to do is we want to be able to plot force as a function of time. So I want to be able to type this, but if I do that right now, it's not going to work because data force is a one-by-one structure. Data force contains all of these fields. The one that we're interested in right now is the force in the vertical direction, the z direction. That means we want data force. So I'm going to call this FZ. Use an underscore there, or just FZ. And say that's equal to data force dot force, which is actually going to give me more than FZ. That's probably going to give me X, Y, and Z. So I'm going to call that F all. And now over here in my right-hand side, I have F all 3 by 5,000. I can just check that that's a real thing and plot F all. So it turns out that MATLAB didn't interpret that quite the way that we wanted it to. It interpreted that as 5,000 different lines with 3 data points each, which is not kind of what we were going for there, but it did plot, there is some data there. We're going to go ahead and pick out FZ, which is probably the third one, X, Y, and Z. And I'm just going to go ahead and say FZ is equal to F all of row 3, comma, all of the values. A colon gets me all of the values. And I'm going to use a tilde or an apostrophe. I'm going to use an apostrophe there to invert the, I'm going to use an apostrophe there to transpose the column. It looks like I've lost my connection to the license server, so I'm going to restart this. You can see over here on the side that that got us a z-force 5,000 by 1, and if we plot FZ now, we should get a graph. We actually want this graph as a function of time though, so let's go ahead and create a new figure using the figure command and plot time comma FZ. That'll give us the time on the horizontal axis and the force on the vertical axis. And it tells us that there's an error because the vectors must be the same length. So that means we did some math wrong in our time vector creation. So we had 500 frames and our frame rate was 100. So time is equal to 0 colon 1 over the frame rate colon the number of frames divided by the frame rate, which gives us over here a 501 double. To fix that, we're going to go ahead, we'll still have the same error using the plot function, so we're going to go ahead and say frame minus 1 divided by frame rate, and now time is a 1 by 500 double. So now if I go use the figure plot command, we still get the same error. We have this mismatch between our time vector, which has a size of 1 by 500, and our force vector, FZ, size of 5,000 by 1. If we dig back into the preferred walking 1, we see that our frame rate is 100 and there's 500 frames. Force is its own separate structure, and if we look at the force data, the force structure, we see that it has its own frequency here because it's sampling at a different frequency. So we're going to go ahead and do rate. I'm going to call it rate for the force plate, FP, is equal to the preferred walking dot one dot force dot frequency. And now rate FP is 1,000, and now we're going to go ahead and repeat our time calculation, but instead of frame rate here, we're going to do rate FP for our force plate. And we can go ahead and do the time thing, and now we can plot time FZ. And it's still not going to like us because it says the vectors must be the same length, and you say, but I just made them the same length. And the answer is no, we haven't made them the same length, and there's a couple of reasons for that. One, here, there's not 500 frames, there's 5,000 frames. Okay, so if we do that, now time over here on the right-hand side becomes by 5,000. So we're off by a factor of 10. We could have done a formula to do that. We're just manually multiplying by 10. But now we're still going to have trouble. Oh, nope, we're not going to have trouble. And we go to our figure. We see that now on the horizontal axis we have time instead of the frame number that we had before. This is an incomplete trial. This is not a good trial, not one we should be using. We don't start collecting data until over here after 4 seconds, and we lose the second half of the trial. Just a reminder that you should always label your axis. So label X label time in seconds will give us on our graph, will give us a label of time, and Y label force in newtons will give us a label on our vertical axis. Will give us a label on our vertical axis. The command window is a great place to explore your data and explore how to use your data, what things work, what doesn't, what size things are. But if you're going to be doing a lot of repetition, if you're going to be using a lot of files, there's all kinds of reasons that it's actually better to go up to the top and write a new script or an M file. So I just did that, and the way I have my Matlab set up, my editor is here front and center because I do most of my work in the editor. The command window gets small down here. I'm going to go ahead and save this file before I start. Always save early, save often. And I'm going to go ahead and save it in the sample data file where we were working. There are ways to save it in a different folder than where your data is stored, and it's actually really good to learn those. Maybe we'll talk about those later in another video. But for right now, I'm going to be in my sample folder, and I'm going to call this plot forces.m. Note, I'm not putting a space in the title. That's important. Don't put a space in the title. MATLAB doesn't like spaces in titles. I'm going to save that. So now I have plot forces.m. The first thing I'm going to do here is I'm going to use the % sign to write a comment, do something that describes what it does. Okay, so in this case, this file reads data from the mocap lab force plates and plots it. I'm going to create a variable called file name. And file name is going to store the name of the file I want to load. So preferred walking _1.mat. And I've used single quotes around it to tell it that it's a string, that it's a file name that I'm doing and not a variable, else MATLAB will think it's a variable. And note that the equal sign turned orange. As soon as I put a semicolon there, that goes away. It's just reminding me to suppress the output. The next thing I'm going to do is I'm going to load file name. The advantage to doing this way is if I have multiple file names that I want to load, I can do something where I would maybe do file name equals preferred walking 1.mat semicolon preferred And I'm going to just go ahead and paste this preferred walking 2.mat curly braces and end the file. Then I can use multiple things. We'll talk more about that later. Right now we're just going to focus on a single file. Load the file name, and if I save this and run it, I'm actually going to go back before I do that, and I like to clear everything, close all the plot windows, and clear the command window at the start of every script, just so that I know that what I'm doing is based on the stuff in my script and not something stored in a variable that I forgot about. So now that I've done that, I'm going to go ahead, I'm going to run it. You'll see plot forces shows up down here in the command window. It's thinking there's no double arrows down there at the bottom of the window. Once you've loaded your data, you can do all of the same things that you had done at the command window. So up here in the editor, we can say forces. Force is equal to the same thing we did before, preferred walking 1 dot forces. FZ then is equal to so it just lost its connection to the license server, so it's upset. And it can't find preferred walking 1.mat because I misspelled it. Preferred walking 1.mat. So we'll try that again. We'll run that again. So if you keep having an error like this, one handy trick is to take the file you want, drag it into the command window, and then copy and paste that up into your script. So, and right now, I'm putting in underscores here where there are spaces. So comparing those two things. So now we'll go ahead and we'll try this one more time. And now we're getting a different error. There's no such thing as forces. So you can interrogate that. You can say, well, what's actually in preferred walking 1? And it's force, not forces. So now I can go ahead and I can do force, and I can run, and I get it with no errors. So then you can go back and you can do all of the same kinds of things that we did before, doing it in here. As you start to do multiple files and trials, it's really useful to be able to do what I was showing you a minute ago, where you put in multiple files here, and the semicolon says you're in a new space. The curly brackets that I'm using mean that you're creating an array instead of a matrix. So you can do this sort of thing. I don't actually have a second file in here right now, so it's going to be upset. But then I can load file name of a variable, and I can run it through a loop. So I can say for I equals 1 to size of file name, load the file name, do stuff with the stuff inside it, and then each time I run, it will load the new thing. So if I go ahead and I run this right now, it should run the first time, and it should throw an error the second time. And actually I have a problem here as well, because this name is going to change the second time. But this is the basic idea of using a loop to use multiple files. So go ahead and play with using M files and using loops to try and expedite your coding process, and bring your questions to class. I'll see you there.